Okay, as promised, the end of, what is this, the Unit 7.3 Part 2 notes. Yeah, sorry about all the story timing that I did today, guys. I forgot that we had a shortened period. So here it is. I figured since I needed to record it, I'd just go ahead and start it from the top because, honestly, I was trying to kind of rush it at the end. So slow it down, make sure it makes more sense for what we're doing here. Okay, so the x plus 3 is what's causing us to have a wrinkle, right? I mean, if it was just a simple what's the expansion here kind of question, well, it would be easy, you know what I mean? You would just use the n choose r, yada, yada, yada. But this x plus 3, yeah, that's causing us an issue. We know we're looking for coefficient for x to the fifth, so we need to figure out our r, basically, that's going to lead us to x to the fifth. The easiest way, not the only way, but the easiest way to tackle this question is to pretend that this 2x minus 1 to the sixth is an object. And I could take this object and I could distribute it to two different things like that. And that would lead me to this expression. We'll put a x and then a 2x minus 1 to the sixth plus 3 times 2x minus 1 to the sixth. There. Well, since they both have a 2x minus 1 to the sixth, what I'm going to do is I'm going to go ahead and find the general term for this expansion, and then I will substitute it in here and here. So what we know is that a is 2x, b is negative 1, and n is 6. Now I'm going to try to write this small. Oh, not even on the screen. I'm going to try to write this small so that I have plenty of space. I don't want to run out of space like I did in class. So let's see. Our general term, I will skip over the t sub r plus 1 stuff just for space purposes. We have n, choose r, a to the n minus r, and b, which is just negative 1 to the r. Now what this is going to do is make our terms oscillate between positive and negative. That's the only thing it's going to do. I am going to try to separate this x out of here because I know I'm going to be looking for an x to the fifth. So we're going to have to play a game for the r values. So let me go ahead and separate these two things. I'm going to move all my constants to the front. So we have 6 choose r, 2 to the 6 minus r, negative 1 to the r. Again, that's just going to bounce between positive and negative. And now I have x to the 6 minus r. Once again, not on screen. So this is my general term, and I can plug this into both of these up here. Again, space purposes. So we'll take this guy and put it there, and take this guy and put it there, and I might as well just bop on down here, because look at all this white space. Equals x, and then the general term. 6 choose r, 2 to the 6 minus r, negative 1 to the r, x to the 6 minus r, plus 3, 6 choose r, 2 to the 6 minus r, negative 1 to the r, x to the 6 minus r. One more simplification before I get rocking on this question, and that's right here. This x is x to the first, and it's being multiplied to the front, but it didn't have to be multiplied to the front. There is no reason why I can't take this x and put it back here with this x, because it's just x to the first. It's not affected by r, like this one is. But, so, why keep it here? No, I'm going to move it back here. And if I move it back here, I'm multiplying two numbers with the same base. So I'd be adding those exponents. This x to the first plus 6 minus r. So this is going to condense slightly to 6 choose r, 2 to the 6 minus r, negative 1 to the, or negative 1 to the r times x to the 1 plus 6, 7 minus r. Over here, there's nothing to simplify, so I'm just going to rewrite that. I can move that 3 to the right side of the choose function, but what's the point? I mean, to be honest with you, we're just going to type it on a calculator anyway, so who cares what order the multiplication is in? There. So let's remind ourselves what we're supposed to be doing here. We're supposed to be finding the coefficient of x to the fifth. Well, if you're looking at this thing right here, these two x's have different exponents. That means there are two different values of r that are going to give me an x to the fifth. So if I wanted this to say x to the fifth, I know this 7 minus r would be a fifth power. So I know that 7 minus r has to be 5. That means for this term to give me an x to the fifth, r would need to be 2. But over here, if this was going to give me an x to the fifth, then 6 minus r would have to be 5. So here r is 1. Now, it's not a problem that I got two different r values. And the reason why it's not a problem is because that's a plus sign. If it was a multiplication sign, we'd be in trouble. But here's what this is going to mean. When we have r equals 2, we will get an x to the fifth out of this expansion. And this is just going to give us an x to the fourth. Nobody cares. We're talking specifically about the x to the fifth. So even though this gives us an x to the fourth, we just ignore it. It's unimportant to us. And the same thing's going to happen when we plug in 1 here. This one will give us an x to the fifth. This one's going to give us an x to the sixth. But they're just being added, so who cares? We'll just completely disregard the x to the sixth. It's unimportant. And then what we're going to do is we're going to take our two different x to the fifth things and combine our like terms, just like we would have if we had done the full expansion. So let's plug in r equals 2 and r equals 1 to their respective places. Again, don't plug in 2 to both of them. It only helps you in one of them. Don't plug in 1 to both of them. It only helps you in one of them. So this first one's going to give me 6, choose 2, times 2 to the, let's see, I'm doing 6 minus 2, so 2 to the fourth. Negative 1 squared, so that'll be positive, x to the fifth. This one would have generated an x to the fourth, but since we're not looking for x to the fourths, we'll just stop caring about it. It's not a like term anyway. They won't combine. And here I'm dropping in r equals 1. So 6 choose 1, which is really easy. That's just 6. And 2 to the 6 minus 1, fifth. Negative 1 to the 1. Ooh, this one's going to be odd. Odd. Negative, excuse me. X to the fifth. We grab out handy dandy calculator and we type those bad boys in. Try to get it on the screen. There it is. Yeah. So math, probability, NCR, doing 6 choose 2 times 2 raised to the fourth. You could do the times negative 1 squared if you want, but of course that's just 1. So 240 x to the fifth. I'll write that in a second after I move my calculator. Now for the second one, 3 times math, 6 choose 1, which by the way is a complete waste of our time to type it, because if you have 6 things, how many different ways could you take one of them? Obviously the answer is 6, but I'm just showing you what you would have done on a test. Times 2 to the fifth, in case you don't know, that's 32, and times, whoops, not there, negative 1 to the first, so just times negative 1. Boom. There we go. So we have 240 x to the fifth minus 576 x to the fifth, which combines to become negative 336 x to the fifth. So the question asks, what is the coefficient of x to the fifth? It is negative 336. And by the way, if you stopped right here, IB still would have given you full credit. They always accept the entire term when they're asking for just the coefficient. Now, if they ask for the entire term and you only give them the coefficient, that's going to hurt you. But when they ask for the coefficient, if you give them the whole term, obviously you knew what the coefficient was. I hope that made enough sense. Please tackle that homework tonight as best to your ability and bring me your questions tomorrow, guys. All right, I'll see you then.